Welcome back to Business Mathematics 2 MA1203. Still, we are going to discuss about system of linear equations. So for this session, we are going to talk about solution to general n variables and equations. So in general, we will call a set of line equation by system of linear equations. In this week, we will just focus on solving system of linear equation when the number of equation is the same as the number of variable involved. Now let's try some example. Find the solution of this equation. Determine whether there is only one solution, infinitely many solution, or no solution at all. This one. Okay. And then this is equivalent when we are writing with the augmented matrix as this. Okay. I want to have x is what, y is what, and z is what. So I want to get this into the upper triangular form. Okay, to make it easier, I will change first the first row and the third row. This is the notation. So I have this. Okay, I want to make this an upper triangular, the row echelon form. So I have to change this into 0, 0, 0. So how can I change this into 0 and 0? Very easy. Minus 2 plus 2 times this. Minus 2 R2 plus 2 times R1. What about this one? 3 minus 1 times 3. R3 minus 3 times R1. So in the end, you have this. Let's look. 1 plus 2 times 2, 5. 2 plus 2 times 1, 4. Minus 3 plus 2 times 2, that is 1. The third row, 3 minus 3 times 1 is 0. 2 minus 3 times 2 is minus 6. 2 minus 6 is minus 4. 1 minus 3 times 1 is minus 2. 4 minus 3 times 2 is 4 minus 6 minus 2. Okay. In order to avoid rational, I want to get this the same. So I want to multiply it. With so that it gives you the same value, the same absolute value. So this is times 4 and this is times 5, just like elimination method. Yeah. So you have 20, 16, 4, minus 20, minus 10, and minus 10. Okay. Yeah. So you have to have this as 0. So what do you have to do? R3 plus R2. This is wrong, yeah? R3 plus R2. So you have, this will give you 0. Minus 2, 10 plus 16 is 6. Minus 10 plus 4 is minus 6. So you have this one. And so you can, okay, so what does this mean? X plus 2y plus z equals 2, 0x plus 20y plus 16z equals 4, and 0x plus 0y plus 6z equals minus 6. That will give you z equals minus 1. So if you can change this into a upper triangular form, this is what we usually call row echelon form. This is you don't have to have this one, you do not have to have this as one, you do not have this as one. But if you have a upper triangular form or something similar than that, that is what we usually call row echelon form. To make the row echelon form precise, you could look for the definition at the textbook. Then by doing back substitution, okay, you have z equals minus 1. And z equals minus 1, you can substitute into the second equation. So you have 20y plus 16 times z is minus 1, equals 4. So you have y equals 1. And you can substitute z equals minus 1 and y equals 1 to the first row. And so you have this one. And in the end, you have x equals 1. So in this linear equation, in this system, you have one solution. That is 1, 1, minus 1. That is one intersection point. Okay, yeah? Okay. What about if we continue this? Okay, yeah? We continue by 1 over 6 of R3. This is wrong, sorry. and 1 over 4 of R2. So you have this one. Okay, but this leaves you z equals minus 1. Okay, so I know what is z. What about y? What about y? Okay, okay. So I want to get rid of this 1 and 4. So if you have 1, the upper and the lower should be 0. The upper and the lower should be 0 to make it more simpler, your calculation. So you have R1 minus 1. And this 4 minus 4 times 1. R2 minus 4 times this. And you should have this one. How can you do this? Look at the first row operation. R2 minus 4 times this, 0. 5 minus 4 times this is 5. 4 minus 4 times 1 is 0. 1 minus 4 times minus 1 is 5. What about this? So I have this one 0, and I have to find this, change this into 0. How do I can change this? By this operation. R1 minus R3. 1 minus 1 will give you 0. 2 minus 0 will give you 2. 1 minus 0 will give you 1. And 2 minus minus 1 will give you 3. Okay, and then you can simplify further. You get this into 1. So you have this. And you want to change this into 0. Okay, you have to have R1 minus 2 of this. 1 minus 0 of this. 0 minus 0 of this. The same. 3 minus 2 times 1 will give you this one. Okay, so now we have similar like identity matrix. If you have 1, all the upper and the lower should be 0. If you have 1, this is what we also call leading 1. Leading 1. So the first column that is not 0 should be 1. Look, the first column that is not 0 is 1. And if you have the leading one, upper and lower should be 0. Upper and lower should be 0. Upper and lower should be 0. If you have this kind of form, we usually call this form is reduced row echelon form. Reduced row echelon. Row echelon form is something like the upper triangular matrix, but reduced row echelon form is something like identity matrix. You will find another example later. Okay, yeah. Okay. Now, okay, let's look at this example. The first example, you have three equations. You have three equations, but the third equation is not there. Is not there. So apparently, this is you just have two equations, but you have three variable. Okay, yeah. If you have the variable is more than the number of equation, usually you have an infinitely many solution. Okay, usually you have an infinitely many solution. So in here also, but very careful. In this form, you have 0x plus 0y plus 0z equals 2. So there are no x, y, z that satisfy the third equation. So in this, you have no solution. Infinitely many solution, no solution. What about this? Okay, z equals 3, but you have x plus 2y plus 4z equals 3. So you have the variable, the number of variable is 3, but the number of equation is 2. So you lack the equation. So there are infinitely many solutions. Okay, this is what we usually call underdetermined system, yeah. Yeah, later. And this one, no solution, yeah, 0, 0, 0, 3, no solution. So a last find condition for k such that the system have no solution. Okay, yeah. To look at this, we have to find a way to look at this, that is using the Gauss-Jordan elimination method. Okay, yeah. So I have 1. I have to set this into 0. R2 minus 2 R1 will give you this and this and this. Okay. So if you want to have this as your so that the system have no solution, you have to set this into 0. So you have 0x plus 0y equals minus 2, and that's impossible. So you have k plus 2 should be equal 0 and k should be minus 2. When k equals minus 2, so you have no solution. Okay, later we will discuss. So do you know the condition so that it has only one solution? Do you know? Yeah, k doesn't uh, cannot equal to minus 2, yeah, so that it has only one solution. How about infinitely many solution? Yeah, cannot happen here. Why? Yeah, let's see. So the last is the application. We will talk in the other session.